Welcome to the first video of the semester. The purpose of these videos is to give you an introduction to the lesson that we will be completing in class. We will be going through some of the examples, but not all of them, so please try to watch these videos before you come to class so that we can finish the rest later. Today we'll be looking mostly at factoring simple trinomials, but first we'll start with a review of common factoring, then getting into factoring trinomials of the form x squared plus bx plus c. We would call these simple trinomials if there's no coefficient on x squared. And then we'll be looking at some additional examples. So first, for common factoring. Think of this as the opposite of the distributive property. Instead of expanding out by multiplying, we're going to be reducing by dividing. Now what we want to do is we want to find a common factor, something that can divide everything in the expression, and we want it to be as large as possible. Now this can be a number to divide the coefficients. It can also be variables as well with exponents. So if I look at 7x squared minus 21x. Now looking first at the coefficients, 7 and 21 have a common factor of 7. They could both be divided by 7, and that's the largest it can go. Now also looking at the variables x squared and x, they have an x in common. I wouldn't be able to divide the second term by x squared because it only has the variable x. So what I'm doing here is I'm going to divide both of these by 7x now. Now you don't have to show the division in the original question, but I like to show it for our lessons. So 7x squared divided by 7x is x. When I divide the second term also by 7x, so 21x divided by 7x, and remember that that's subtraction there, that will be minus 3. Now remember how I said this is the reverse of the distributive property. What you can notice, if you multiply 7x times x, you get 7x squared. Multiply 7x times negative 3, you get minus 21x. So that's how you know if you've done this correctly. We'll go through these other two examples on common factoring in class, but that's the basics. So now looking at factoring simple trinomials. Now remember how I said it's the opposite of the distributive property, factoring. Well, if you think about it, in our previous lesson, we were multiplying binomials. We were expanding them, and our answers were looking like trinomials. So what we're doing here is we're going backwards. We're starting with a trinomial like this, and we want to turn it into the multiplication of two binomials in this form here, x plus m times x plus n. Now the question is, how do we figure out what those numbers would be, m and n? So here's the trick that we're going to do. The two numbers that we're finding, the two numbers m and m, have to satisfy two conditions. They have to add to b, which is the middle term or the coefficient on x. Those two numbers must also multiply to c, which is the final term or the constant term in the trinomial. So take a look at an example. If I scroll down a bit here, we have n squared minus 5n minus 24. Now this is not necessary, but you can write off to the side that you need to think of two numbers that add to. Now always look at the sign in front. It has to add to negative 5, and it has to multiply to negative 24. Now, you can think of two numbers that do that. You can pause the video, try to think of it yourself if you like, or you can watch me do it. Now, a few little tricks here. I know that we're multiplying to a negative number, so I know that one number must be positive, one number must be negative. That's the only way that you can multiply to a negative number, by having different signs. What I also know is because they're adding to a negative number, I know that the negative number will have to be larger, it will have to be bigger. So if you think of some numbers that multiply to 24, for example, there's 12 and 2. So I could say negative 12 and positive 2. Now they multiply to negative 24, but they do not add to negative 5. So I know those are not the numbers that I want. Remember that it has to satisfy both of those conditions. So if you think about it now, the two numbers would be negative 8 and positive 3. They both add to negative 5 and multiply to negative 24. That's what we want. So this means that when we factor this, we will get n plus 3 times n minus 8. Now it doesn't matter if the negative 8 comes first and then the positive 3 last. It doesn't matter what order you multiply numbers in, you're going to get the same result. So this is the factored version of n squared minus 5n minus 24. Now, like I showed you previously, you can go backwards when we're factoring and expand, and you should get the original question. So you can expand if you like, n plus 3 times n minus 8. You can expand it, and we will in fact get n squared minus 5n minus 24. That means we're correct. So we're going to do the rest of the examples in class, but there's your little refresher on common factoring and factoring simple trinomials.